Ever pondered why the language of mathematics is universally understood, even by aliens in our sci-fi fantasies? Just like the rhythm of music or the colors of a painting, mathematics transcends the barriers of culture, language, and geography. It's a language that speaks through symbols and equations, a language that is understood by everyone, everywhere. Mathematics is more than just numbers and equations. It's a language that describes the complexities of the universe, the structure of a snowflake, or the trajectory of a rocket. It's a language that doesn't need translation, because it's based on universal principles that hold true whether you're in New York, New Delhi, or even on a distant planet in another galaxy. Just imagine a world without math. It's almost impossible, isn't it? Because math is not just a subject we learn in school, it's a universal language that forms the foundation of our understanding of the world. So, how does math accomplish this universality? Let's dive in. Think about it. Math, unlike any spoken language, doesn't change from country to country. This universal consistency of mathematics is truly extraordinary. From the bustling streets of New York to the remote villages in Bhutan, the principles of math remain the same. This constancy is the reason mathematics is often referred to as the universal language. Consider the number system we all use. Whether you're in Tokyo or Timbuktu, the number 5 will always represent the same quantity. This consistency allows us to communicate complex ideas across languages and cultures. If you show someone the equation 2 plus 2 equals 4, no matter where they are from or what language they speak, they will understand it. But the universal language of math goes beyond just numbers. It encompasses a broad range of symbols and principles that are recognized around the world. Take, for instance, the Pythagorean theorem. This mathematical principle, discovered by the ancient Greek mathematician Pythagoras, states that in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. This theorem holds true whether you're calculating the distance between stars in an observatory in Chile or working on a construction project in China. This ability of math to transcend linguistic barriers is truly remarkable. It allows scientists from different countries to collaborate on complex projects, like the International Space Station, or global health researchers to track and predict the spread of diseases. It enables engineers across the world to build structures that stand the test of time. Indeed, the language of mathematics, with its symbols and principles, is a powerful tool for communication and discovery. It's the common thread that links us all, regardless of where we come from or what language we speak. So why is math a universal language? Because it's consistent, clear, and transcends cultural and linguistic barriers. That's the beauty of mathematics. It's the same in every corner of the world. But it's not just about humans. Nature, too, speaks the language of mathematics. It's quite fascinating to think about how mathematics, this abstract concept conceived by human minds, is embedded deeply in the natural world. Let's take a moment to appreciate how nature embraces mathematical principles, often in ways that are beautiful and elegant. Consider the Fibonacci sequence. This is a series of numbers in which each number is the sum of the two preceding ones, usually starting with 0 and 1. Now, if we observe nature closely, this sequence shows up in the most unexpected places. The arrangement of flower petals, the layout of pine cones, the branching of trees, all of these often follow the Fibonacci sequence. Isn't it amazing? This simple sequence, a creation of human thought, mirrored in the design of the natural world. And then there's the golden ratio, another mathematical concept that nature seems to love. This ratio, approximately equal to 1.618, is often found in the proportions of various natural phenomena. From the spirals of galaxies to the proportions of the human body, the golden ratio is a constant companion. This ratio is so prevalent, it's often considered a hallmark of beauty and balance in art and design. These patterns, the Fibonacci sequence and the golden ratio, are universally recognized. They are evidence of a certain mathematical order underlying the chaos and randomness of the natural world. It's as if nature itself is a mathematician, using numbers and ratios to shape and structure its creations. This brings us to a profound realization. Mathematics isn't just a human invention, it's a fundamental part of the universe, a language that transcends cultural and species boundaries. It's found in the stars above us, the trees around us, the very bodies we inhabit. Math is nature's language, a language that every living thing unknowingly understands. What about communication with extraterrestrial life? Could math be our common language? Now this is where things get intriguing. If we ever do come across alien life forms, how would we communicate? Words, gestures, or even images may not make any sense to them. However, we might find common ground in the language of mathematics. So why mathematics? Well, it's because math is a universal constant. It doesn't change whether you're on Earth, Mars, or even in the farthest reaches of the universe. The principles of mathematics remain the same. 2 plus 2 will always equal 4, no matter where you are. Let's take a look at a real-life example of this, the Arecibo message. In 1974, a team of scientists led by Dr. Frank Drake and the legendary Carl Sagan decided to send a message into space. This wasn't just any message, though. It was a binary coded message, a series of ones and zeros based on mathematical and scientific facts. This message was designed to be simple yet informative. It contained information about the human species, the DNA molecule, our solar system, and even the Arecibo radio telescope itself. All of this was communicated using the language of mathematics. The purpose of the Arecibo message wasn't really to make contact with alien life. The chances of that are astronomically small. No, the real purpose was to demonstrate the power of math as a universal language. It shows that we can use math to communicate complex ideas, not just to other humans, but potentially to other intelligent life forms in the universe. So, if we ever do encounter aliens, math might be our best bet for communication. It's a language that doesn't rely on culture, history, or even biology. It's a language based purely on logic and reason. In a universe where so much is unknown, this could be our one solid connection. In the cosmic arena, math might just be our universal translator. Understanding math is not just about solving equations. It's about understanding the world around us. Math is an essential tool in our daily lives, whether we realize it or not. It's not just confined to the four walls of a classroom or a complex scientific theory. It's intricately woven into the fabric of our everyday existence. Consider this. Every time you check your bank account, plan a budget, or calculate how much time you have left to reach your destination, you're applying math. It's the language of logical reasoning and problem solving, skills that are invaluable in life. Financial literacy, a skill that every adult needs, is grounded in mathematics. From understanding interest rates to making sense of your paycheck, math proves its importance. But math goes beyond practicality. It's also the key to understanding the world around us. It helps us recognize patterns, make predictions, and understand how things work. Take a look at nature, for example. The Fibonacci sequence, a famous mathematical concept, is seen in the arrangement of seeds in a sunflower, the spirals of a pine cone, even the pattern of a nautilus shell. It's astounding how math manifests itself in the natural world. And let's not forget about technology. Every digital device, every app, every video game runs on binary code, a language entirely based on math. Coding, data analysis, artificial intelligence. They're all powered by mathematical principles. Mathematics is also the backbone of scientific understanding. It's the language used to describe and prove theories in physics, chemistry, and biology. Without math, we wouldn't have been able to land a man on the moon or decode the human genome. So, it's clear that understanding math is about more than just crunching numbers. It's about problem solving, logical thinking, and understanding the world we live in. It's about being able to make informed decisions and solve complex problems. In a way, being fluent in math is being fluent in the language of the universe. So we've taken quite a journey today, haven't we? Let's take a moment to reflect on what we've explored. We started by understanding how mathematics is truly universal, its principles staying consistent regardless of culture or geographic location. We then moved on to the language of mathematics, and how it serves as a tool for communication that transcends linguistic barriers. Our journey took us into the natural world, where we saw mathematics at play in everything from the spirals of a seashell to the orbits of planets. We even ventured into the realm of the extraterrestrial, discussing the potential role of mathematics in communicating with alien life forms. Finally, we underscored the importance of understanding this universal language, as it holds the key to unlocking mysteries both here on Earth and far beyond. Next time you solve a math problem, remember, you're speaking the universal language of the universe.